Hello there, this is Professor Evans. This video is for the students in COP 1000C, which is Intro to Programming Concepts at Valencia College in Orlando, Florida. In this video, we're going to discuss Unit 5, which is Control Structures Part 2, which covers repetition. So as you work through this unit on MindTap, here are the learning objectives that you're going to go through for Unit 5. You'll learn how to identify the need for repetition control structures, distinguish the use of while loops, including for, do, and EOF. You're going to learn how to write if and else statements, test, break, and continue statements, build nested control structures, and identify methods to prevent bugs and debug loops. So in this video today, I'm going to go over 4 basic examples to introduce you to the idea of loops, and then you can use these examples in order to help with your MindTap exercises for Unit 5. So I have 4 examples. I'm going to start with example 1, and our program objective for example 1 is we're going to write a program that computes the sum of all even numbers from 2 to 100. That's it. We're just going to figure out the sum of all even numbers from 2 to 100. So in this case, if we think about the inputs, there are none. The user is not supplying anything in this case. Our outputs is going to be sum, where sum is two plus 4 plus 6 plus 8, etc., all the way up until 100. So now let's talk about our process for doing this calculation to get the sum of all the even numbers. The first thing we're going to want to do is define a variable. We're going to call it num, and that is going to hold the value of the even number to be added to sum. Okay, so we're going to have our sum, and we're going to add a certain amount to sum. That amount we're going to add to sum is going to be stored in num. So that's sort of like a temporary variable, or a variable we're going to use inside of our code, but it's not a variable that's going to be part of our output. So we need to define sum as well, which will be our output. So we're going to have 2 variables that we're going to use within this code, num and sum. So we're going to use a for loop to repeat a calculation for sum. And here's what our loop will do. Add num to sum, increment num by 2, and repeat until 100 is reached. So if we think about how this is going to work, let's say that I have num, and I say that num is going to be equal to 2. And let's say that I have sum, which starts off at 0 because I haven't added anything to it. What I want to do is add sum and num together, increase num by 2, and then repeat. So I want to have a loop where I take the old sum, which is right here, I add something to it and store it back into sum. So I'm updating the value of sum. So let's walk through this. Let's say that I start out with sum is 0 and num is 2. So after the first iteration, sum would equal 0 plus 2, and num would equal 4. After the second iteration, and by iteration I mean a run through the loop. So after the first run through the loop, we're going to have sum becomes 2 and num becomes 4. After the second iteration, sum is now going to be 2 plus 4, because in the first iteration we changed sum and we changed num. So sum is now going to be 2 plus 4, and num is going to now become 6. After the third iteration, sum is now going to become 6 plus 6, which is 12. And num is going to again increase by 2. So if we set up a loop to do this for us, we'll be able to add all of the even numbers between 2 and 100 and get that sum. So this is sort of how our loop is going to work. When we set up our loop, we're going to start with num is 2, sum is 0. And within our loop, we're going to continuously add sum and num together, increase num by 2, and then repeat, 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 repeat. So this is the idea of repetition. This is an example of where for loops are extremely helpful because I don't have to sit and write a bunch of lines of code to add up essentially 50 different numbers together. So I'm going to erase this because this is just me sort of talking through our thought process here. And I'm going to go ahead and begin our code now. So I have my pound include statement, my namespace statement, and now I'm going to begin the main program. So I'm going to go ahead and declare num, set it equal to 2. I'm going to declare sum and set it equal to 0. And now I'm going to set up my for loop. So when we set up a for loop, we typically have an index. That index is sort of the number of times you want the loop to run through. So I'm going to define a new integer called I, and I typically stands for index. And when we set up a loop, we have to initialize I to a value. I'm going to say I is going to start out at 0. And I'm going to run this loop up until a certain condition is met. In this case, I'm going to increment num by 2, which means if I'm going from 0 to 100, I'm going to be adding my numbers. I'm going to add 50 times, or I'm going to run through this loop 50 times. So what I'm going to do is set a condition that will cause the for loop to end. We're going to start I at 0. We're going to increment I one at a time until I gets to 50. So this loop right here, this statement right here says set up a loop where I have an index called I, or I'm going to start that index at 0. I'm going to go until that index is no longer meeting this condition. So as long as I is less than 50, I'm going to continue this loop. When this statement is no longer true, the loop will automatically exit. And I'm going to increment I 1 at a time. So every time the loop executes, I will increase by 1 value. So basically, I've set up a statement here where this loop will run 50 times. That's what this statement does, 50 times. Now, within the loop, I'm going to add some brackets because I have multiple things I want to have happen. So remember, we have to control what happens after a for statement or an if statement or a while statement. We have to control what happens by adding brackets if we have more than one line of code that we want to execute within that particular statement. So in this case, I have a for loop and I want to add sum to num and then increase num by 2. So what's going to happen when I run this loop is exactly what we discussed earlier in the process. The first time through the loop, sum is going to start out with 0. It's going to be sum plus num. So I'm going to have 0 plus 2 stored in sum. Then I'm going to add 2 to num. The second time through the loop, I'm now going to add 4 to the sum. The third time through the loop, I'm adding 6 to the sum. The fourth time through the loop, I'm adding 8 to the sum, and I'm just going to keep looping 50 times. And I'll reach all of the numbers between 2 and 100. Again, I'm looping 50 times because I'm going through 100 numbers, but I'm only counting the even numbers. So there's 50 numbers that I'm going to be adding up here. And once I'm done with my loop, I just need to print the output. So when I'm done, I'm going to print the output. Let's go ahead and run this and make sure that everything is correct. All right, so I'm compiling my program and I have an error. I want you guys to see if you can figure out what the error is before I try to fix it. I'll give you a second, see if you can figure out my mistake. If you look right here, I spelled namespace wrong. And I can see that it now turns orange, letting me know that I've corrected that mistake. Let's check again for any more errors. All right, so our program is run. Remember, there's no input from the user, so it's just going to run and tell us the output. And we see that the sum of all even numbers between 2 and 100 is 2,550. So our loop is effectively adding up those numbers for us. Without a loop, I'd have to sit here and use more lines of code to accomplish the same function. So when you're repeating the same concept or the same calculation over and over and over again, it is nice to use a loop. So remember, what happens with this loop is it's going to run 50 times. And if you want to see that in action, we can actually add some cout statements within the loop so that we can see that loop running. For example, let's add a cout statement right here. So if you have trouble conceptualizing how a loop works, this will help you see what's happening within the loop. So I'm going to hit run, and now we're going to get a bunch of lines. Nope, I need a space right here. All right, so now we can see every time this loop runs, we're printing a message to the screen. If your loop doesn't work properly, this is a great troubleshooting technique, is to add a cout statement within the loop and display the values of some of your variables to make sure that they're correct. So we can see that the first time the loop runs is loop 0. Sum is 0. Oh, I need another space right there. Now we can see it clearly. The first time the loop runs, I is 0, sum is 0, and num is 2. The second time the loop runs, sum is now 2 because it added 0 and 2 together, and num has gone up by 2. The third time the loop runs, the index, remember the index started at 0, so our first iteration begins with an index of 0. And so we're really going to run from 0 to 49, which is 50 loops total. 50 loops total. 0 to 49 is 50 loops total. So when we get to loop 3, that's our fourth time through, and we can see that the sum is 6 plus 6, and num has become 8. On our next iteration, the sum is 12 plus 8 is 20, and num goes up. So we can see that num is going up by 2 every time the loop runs, and we can see that sum equals the previous sum plus previous num every time the loop runs. And we're running that until we get up to num is 100. And so if you have trouble conceptualizing a loop and what's actually happening, add a cout statement within your loop that displays the index and whatever variables you happen to be looking at within that loop. It'll help you to conceptualize what's happening a little bit better. So that is example 1. Next, I'm going to move on to example 2. All right, so I'm going to delete this and move on to example 2. In this program, we're going to ask the user to enter 10 numbers and compute the sum and average of the numbers entered. So in this case, we are going to have some inputs. We're going to have 10 numbers from the user. Outputs: the sum and average of the 10 numbers entered. So let's talk about our process here. So I could declare 10 different variables for each of the 10 numbers, and then I could use 10 cout statements to ask the user 10 times to enter a number. but I'm repeating the same action over and over again. I am asking for a number and collecting that number. And this is another great example of where a for loop would be more efficient. More efficient meaning less lines of code. So for our process, rather than declaring 10 variables to hold each number from the user, we're going to use a loop to collect the 10 numbers. Also, within the loop, we're going to add each additional number entered to the sum. Upon exiting the loop, calculate the average. So keep in mind with this program, there's no requirement to output the 10 numbers entered. So I only need to collect a number and add it to a total. I don't have to save that number individually by itself. That's not part of the program description. That's not part of the objective. So what I'm going to do is set up a loop where I ask the user to enter a number and immediately just add it to sum. I'm going to let that loop run 10 times, and then when I'm done with the loop, I can calculate the average by dividing my sum by 10. So that's going to be my process. So let's begin our program. So we're going to define our variables. We have sum, average, and then I'm going to define num as the value or the variable that's going to hold the value from the user before I add it to sum. So I'm going to set up a loop. So once again, I have to define that index. We're going to call it I. This time I want the loop to run 10 times. So I'm going to say I less than 10, I plus plus. So this is how I set up my loop. Remember, I want to run 10 times, so I will count from 0 to 9, which is 10 times through the loop. Typically, it's just standard practice to always start your index at 0, especially because when we start talking about arrays, you will want to make sure that you always start at an index of 0. However, if I were to change this and say that I goes from 1 to I less than 11, then my index would count 1 to 10. I could even make less than or equals to. I could make this greater than, and I could let I count down. I could let I be multiplied by something and loop that way. So I don't necessarily have to have I count up in order. It just depends on your application. So we can change some of the parameters for our for statement, but in this case, I'm going to set this up the way we would do this normally, which would be to start our index from 0, go I less than 10, and I goes up by 1. So I'm going to have an index that counts 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the loop will exit because after that point, I is no longer less than 10. Remember, 10 is not less than 10. 10 is equal to 10. So once I becomes 10, this condition is now false, and the loop will exit. So inside my loop, I need to ask the user for a number. I need to collect that number. And then I'm going to immediately add it to my sum. Remember, I don't have to remember what the number is. So I'm going to collect the number and immediately add it to sum. That means I don't really know what the 10 individual numbers are, but that's not important for this program. I just need to add them all together. So this loop is going to run 10 times. I'm going to collect 10 numbers. Once I've collected those 10 numbers, now it's time to compute the average. So there's my average. And now I'm going to print out my results to the user. And that's going to complete my program. Let's go ahead and hit that run button and make sure that there are no errors. All right, take a look at what I got. See if you can figure out what I'm missing. It tells me the error is on line 33. What am I missing on line 33? Right here, I'm missing an extra caret symbol. Let's go ahead and run again. All right, now I'm ready to enter some numbers. I'll go ahead and expand this so we can see. All right, let's say that I enter the number 25, 5, 32, 16, 28, 100, 2,347, 0, negative 50, 4. There's my 10 numbers. So I can see on the screen that I have my sum and I have my average. So one thing that you'll notice with the output is that I get the correct sum. The average is 250. You might be wondering, if I take the sum, which is 2,507, divide by 10, wouldn't that be 250.7? You're correct, but remember that we defined everything as an integer. So sum, average, and number are all integers. So the output that I'm going to get out is going to be from integer division. If I wanted to make sure that the average was a decimal, I would need to change this to float or double. So let's do that and see if we get a different result. So I'm going to go ahead and type in the same numbers. I had 25, 5, 32, 16, 28, 100, 2,347, 0, negative 50, and 4. So we still see that the average is 250. Let's make them both double because we're doing an integer divided by 10 right here. Now we have the average is a decimal. So we have to look at our variable types in order to make sure we get the output that we want. When everything was an integer, we're going to get integer values when we divide them. If I want to have a decimal value in my answer, I need to make sure that my variable type is going to allow that. So in order to do that, we had to change sum and average both to double, so that when we divide sum by 10, we take a double value and divide it by 10, which will give us a double value to be stored in average. When I left sum as an integer, we had an integer divided by 10, so we still got an integer out that was saved into average. So variable types make a difference in the output that you're going to get when you perform mathematical calculations like this one. And that's going to wrap up example number 2. Now I will go on to example number 3. Oh, actually, you know what? I'm going to keep what I had before because we're actually just going to modify it slightly for example 3. So in this program, we're going to write a program that asks the user to enter several numbers until the user enters 0. So we don't know how many numbers are going to be entered. The user has their choice. They can enter as many numbers as they want. When they're done entering numbers, they'll enter a 0. Once the user enters 0, calculate the sum and average of the numbers entered. So we're changing it up slightly. Our inputs are going to be an unknown amount of numbers from the user, as many as the user wants. And then our output will be the sum and average of the numbers entered. We no longer have 10 numbers, we have some unknown number of numbers. Here's where we're going to use a while loop instead of a for loop. For loops are great when you know exactly how many times you want that loop to execute. I know if I'm collecting 10 numbers, I need a loop to run 10 times. But in this example, I don't know how many times the user is going to want to enter in a number. So what we're going to do is use a while loop. Because a while loop will let you run a loop indefinitely until a certain condition is reached. And that'll allow us to give the user the power to enter as many numbers as they want instead of only giving them 10 opportunities to enter in a number, like we saw in example 2. So we're going to use a while loop to collect the numbers until the user enters 0. In order to calculate the average, we need to know how many numbers were entered. So we're also going to have to count the number of numbers entered within the loop. So just like in example 2, we're going to add each additional number that is entered to the sum, but then we're also going to count the number of numbers the user has entered, or the amount of numbers the user has entered. Upon exiting the loop, calculate the average. So now this is our strategy. So we're still going to have our pound include statement, our namespace statement, and then when we begin our program, I'm now going to add another variable. I'll put these back as integers for now. I'm going to add another variable called count. And this is going to count it's going to store the amount of numbers entered by the user. So how we're going to begin this program is we're going to start with asking the user to enter a number. And we're going to collect that number. Here's where we're going to start our loop. And our condition is, as long as the number is not 0, run the loop. So a while loop begins with the word while, and then you have your condition. The condition will determine when the loop stops running. As long as num is never 0, this loop will run forever. Your program will run forever. So this loop is going to just run over and over and over. There's no index. We're not counting the number of iterations here. It's going to run forever until it receives a 0 in the variable num. So as long as num is not 0, what do we want to do? We want to add each additional number to the sum, count the amount of numbers the user has entered, and then ask for another number. So that's what we're going to do. We're going to add sum to num and store it in sum. So we're going to update the sum. We're going to count the number of numbers entered. So every time this loop runs, we have a counter. If I entered 47 numbers, this counter will count up to 47. So every time this loop runs, I'm incrementing my counter to know how many times did a user enter a number. So once we've updated the sum and counted the number of numbers or the amount of numbers entered, we need to then ask the user to enter another number. So I'm going to copy and paste this statement here. Now you might be wondering, why do I need this first? Well, if you think about num, we initialized it to be 0. So if I don't ask the user to enter something else, if I take that away, if I initialize num to be 0, and my while statement says while num is not equal to 0, this will never run based on my initial value. And because I don't know what the user is going to enter first, I don't want to change this to something else. I don't want to alter the sum in any way by putting a 10 in here or a -2 or whatever. I don't want to alter the sum by putting anything other than 0 as my initial condition for num. So I have to start by asking the user for that first number before I start my loop. Otherwise, this loop will never run and the user will never be able to enter into number because of how we initialized num, and that the condition for the while loop is that num can't be equal to 0 in order for this to run. So now that we have taken in the first number, assuming that the user did not enter a 0, we'll fall into this loop. We'll add whatever they entered to sum, we'll count that number, and then we'll ask for another number. And this will just continue to run over and over and over and over and over until the user enters 0. If the user never enters 0, the program will never stop running. Once we complete the while loop, the next thing that we want to do is display the sum and calculate the average. Now in this case, my average is now going to be sum divided by count, because count represents the number or the amount of numbers that were entered. So instead of dividing by 10, I'm dividing by count, because I don't know how many numbers the user is going to enter in this case. So I have to count those numbers and then use that to calculate my average. Let's go ahead and run this. And now we can see in the console, it's going to ask me for a number. And I can keep entering numbers for as long as I want. It's just going to keep asking for numbers. And when I finally enter 0, it'll stop the loop, calculate the sum and average, and display it on the screen. So with a while loop, you want to use these when you have no idea how many iterations you need. You just know what condition would be required to stop the loop. So every time that you see this enter a number after the very first time, it's from the loop, and it's just collecting the number and updating the sum. So a while loop is useful when you don't know how many iterations you need, but you do know a condition that should cause the loop to exit. That's when you want to use a while loop. A for loop is useful when you know, okay, I need to run this X amount of times. So that's a big difference between for and while. So that'll conclude example 3, and now I'm going to do our last example for this video, which is example 4. And example 4 is, again, building off of example 3. So in this one, we're going to ask the user to enter several numbers until the user enters 0 once again. Once the user enters 0, we're no longer going to calculate sum and average. We are going to determine the largest number that was entered and display it on the screen. So now, instead of just adding numbers together, we have to figure out what the largest number was entered from an unknown amount of numbers and then display that number on the screen. Our inputs are then still the unknown amount of numbers from the user, as many as the user wants. Our output is going to be the largest of the numbers entered. In this process, we're still going to use a while loop to collect the numbers until the user enters 0. Within the loop, we need to somehow have a way to figure out if a larger number has been entered than before. So within the loop, we're going to compare each new entry to a variable called large, which holds the largest number entered so far. Upon exiting the loop, display the largest number entered. So we're altering our approach slightly here. We're still going to have num. We no longer need count because we're not counting the number of numbers entered. We don't need sum or average because we're not calculating a sum or an average. We do just need another variable called large. And I'm going to initialize large to be the absolute smallest large could be. So as an integer, this is as small as I can make it, negative 999,999. I have this variable called large. Anytime the user enters in something bigger than this, I'm going to replace large with that value. And I'm going to continue looping through and doing a comparison. If the new number entered is bigger than large, save that number instead. So let's say that I run the program and I enter in a 1. Well, large is going to go from negative 999,999 to the value of 1. If the next time the loop runs, I enter in a 7, then 7 will be saved in large. If I enter in a 2, nothing happens. Large stays at 7. And so on and so forth until the user enters in a 0. So we're still going to begin with asking the user to enter that first number. And we can even change this a little bit so that we know the first number versus the other numbers. So inside of our loop, what we want to do is compare the number the user entered to large. So if whatever the user entered, if it's bigger than large, well, what do we want to do? We want to save that number inside of large instead. So we're going to set a new value for large, and this is now the largest number entered, if num is bigger than large. Then we're going to continue in this loop asking the user to enter more numbers until they decide to enter 0. Once they're done, we are going to display the largest number entered, which is going to be stored in large. Large is going to store our value for the largest number entered. Let's go ahead and run this and see how it works. Okay, so we can see enter the first number, so I know I'm right here in my code. I'm going to enter in a 7. Now it says enter another number. Now I know I'm in the loop. So I'm going to enter in a 3, a negative 9, 14, a negative 56, 400, and 12. I enter 0 to say I'm done. Largest number entered was 400. So every time I enter a number, it compares it to the largest number seen so far. When I entered a 7, 7 is bigger than negative 999,999, so large is now 7. When I entered the 3, that's not bigger than 7, so the 3 was essentially ignored. When I entered the negative 9, that's not bigger than 7. It was ignored. When I entered the 14, large became 14. If you, again, need more clarity on seeing how that works, what you can do is add a cout statement right here inside your while loop. So let's say that you want to know the value of large every time the loop runs. I can add that in there so now I can see what's happening. So if I run this again, I'm going to enter my first number. Large is currently 7. I'll go ahead and add an end line to this so that we can have some better spacing. All right, enter the first number. Large is currently 7. If I enter in another number, large is still 7. If I enter in 10, large is now 10 because 10 is bigger than 7. And so you can add these little cout statements into your code if you need help visualizing what's happening every single time the loop runs. So in this case, let's say that I exit, I'm done. Large is 10 because that was what large was in our loop, and I didn't enter anything bigger than 10. So that's how we can use these little cout statements to see what's going on inside of a loop. And it might help you to visualize it if you have a hard time understanding what is the loop doing and how many times is it running. So that concludes my 4th example on repetition and using for loops versus while loops. As usual, if you have questions, please feel free to email me, reach out on Canvas, or send me an email message. Thank you all for watching, and I'll see you next time.